Somewhere beyond the familiar planets of our solar system, beyond the blue light of Earth, beyond the pale rings of Saturn, beyond the cold and distant path of Neptune, there is a world that seems almost too strange to belong to reality. It is not blue like Earth. It is not red like Mars. It is not golden like Saturn, or storm-striped like Jupiter. It is a giant world with a faint, rosy glow. A world often remembered by a simple and beautiful nickname: the Pink Planet. Out there, in the quiet dark, this distant object circles a star much like our sun. It does not shine with its own true starlight. It does not burn like a sun. It does not send warmth across a family of planets the way our star does. Instead, it glows faintly from the heat still left inside it. Heat from the time it was born, long ago, when gravity pulled gas and dust together and shaped it into something enormous. And from far away, through the eyes of our telescopes, that leftover warmth gives it a strange color. Not a bright candy pink, not the simple pink of a sunset cloud, but something deeper, a dull magenta, a dark cherry blossom shade, a soft, smoky rose hidden inside the blackness of space. It is the kind of color that feels impossible at first, as if the universe has quietly painted one of its cold giants with the memory of a flower. But this world is not gentle in the way a flower is gentle. It is enormous. It is cold compared with many young giant worlds we have studied. It is far from its star, and it does not have a surface where oceans gather, where mountains rise, or where footsteps could ever press into soil. If you could drift toward it in a silent spacecraft, you would not see continents or islands. You would not see rivers catching sunlight, or clouds casting shadows over land. You would see only atmosphere, layer after layer of atmosphere, a deep sky without ground, a giant sphere of gas, haze, chemistry, and cloud. And the closer you came, the stranger it would become. The pink glow would slowly fill the window. At first, it might look like a dim, rose-colored marble suspended in space. Then, as your spacecraft moved nearer, the small, distant dot would grow into a world. The edges would soften, the darkness behind it would deepen, the star it circles would become just a bright point off to one side, too far away to make this place feel warm or familiar. And then you might begin to notice something moving across its face. Not oceans, not weather systems like the ones we know, but vast layers of cloud, clouds that do not belong to Earth. On our planet, clouds are made of tiny droplets of water or crystals of ice. They gather above oceans and forests. They drift over cities. They become rain, snow, thunderheads, fog, and the soft white blankets we watch from airplane windows. Clouds are so familiar to us that we almost forget how strange they really are. A cloud is matter floating in the sky. A cloud is a world's atmosphere becoming visible. And on other worlds, where the temperatures are different, where the chemistry is different, and where the air is made of different gases, clouds can be made from things that would seem impossible here. On Jupiter, clouds may contain ammonia. On some ultra-hot exoplanets, clouds may involve minerals, silicates, or metals. And on this distant pink world, the James Webb Space Telescope has revealed something even more dreamlike. Its clouds may be rich in salt, not salt like a shaker on a table, not salt scattered on the edge of a sea, but tiny salt-bearing particles suspended in an alien atmosphere, veiling the deeper layers below, changing the light that escapes into space. Clouds made not from the water cycle we know, but from chemistry written under a different sky. A salty haze around a pink giant, a mineral weather system in the dark. This is what makes GJ504b so haunting. It is not only that it looks beautiful, it is that the beauty is attached to a real physical mystery. For years, this faint companion was difficult to study. It was too dim, too distant, and too close to the glare of its star for older instruments to easily read its atmosphere. Astronomers knew it was there. They knew it was unusual. They knew it had a color that captured the imagination. But the details of its sky remained hidden. Then came the James Webb Space Telescope. JWST does not travel to these worlds. It does not cross the darkness between stars. It does not send back photographs like a spacecraft flying past Saturn or Neptune. Instead, it waits near Earth and listens to light. Very faint light. Ancient light. Light that has left a distant world, passed through or emerged from its atmosphere, crossed the emptiness between stars, and finally arrived at a golden mirror floating in space. In that light, there are clues. Every molecule leaves a trace. Water vapor leaves a trace. Methane leaves a trace. Carbon dioxide leaves a trace. Ammonia leaves a trace. And clouds, too, can leave their own quiet signature, not by speaking clearly, but by hiding what lies below. That is one of the most beautiful things about astronomy. We do not need to touch a world to begin knowing it. We do not need to stand beneath its sky. We do not need to feel its winds or fall into its clouds. Sometimes, a single thread of light is enough to tell us that somewhere, far away, a strange atmosphere is moving. And in the case of the pink planet, that light carried a surprise. When scientists tried to recreate what JWST saw, something did not fit. The atmosphere did not make sense at first. The chemistry seemed incomplete, as if some important layer of the world was missing from the picture. Then they added clouds. And not just any clouds. Salt clouds. Suddenly, the model became more physically possible. The strange light began to make more sense. The deeper molecular signatures were softened, veiled, shaped by a cloudy layer above them. And with that, the pink planet became even stranger than its nickname. It was no longer simply a distant magenta world. It was a world with weather made from minerals. A cold, massive, ancient companion wrapped in salty skies. A place where the familiar idea of a cloud becomes unfamiliar again. And perhaps that is why this world feels so perfect for a quiet journey. Because it does not frighten us in the usual way. It does not explode. It does not destroy. It does not rush toward us. It simply waits in the dark, circling its star, glowing faintly with the heat of its past. A pink world, a silent giant, a place where clouds may be made of salt. And as we begin this journey, we are not only traveling toward one unusual object, we are traveling toward a larger idea, that the universe is filled with skies we have never imagined. Skies without blue, clouds without water, weather without oceans, worlds without ground, and light that carries secrets for more than 50 years before finally reaching us. So, for a moment, let Earth become quiet behind us. Let the familiar planets fall away. Let the sun shrink into the distance. And let your mind drift outward into the deep and patient dark, toward a faint, rosy point of light. Because far beyond our solar system, around a quiet, sun-like star, the pink planet is waiting. And its clouds are not like ours. Before we can reach the pink planet, we have to leave behind everything familiar. Not quickly, not with violence, but slowly, quietly, as if we are drifting away in a dream. Below us, Earth turns in silence. The blue oceans catch the sunlight. White clouds curl over the continents. Thin ribbons of atmosphere glow along the edge of the planet, the fragile blue line that holds every breath, every storm, every forest, every city, every sleeping creature we have ever known. From this distance, Earth does not look loud. It does not look divided. It does not look crowded. It looks small, bright, and impossibly delicate. A blue world wrapped in water clouds. The only home we know. And for a moment, before we leave it behind, it is worth remembering how strange Earth is, too. We are used to its skies, so we forget that they are rare. We are used to clouds made of water, rain falling from the air, oceans reflecting sunlight, and a moon hanging above the night. But from the viewpoint of the universe, Earth is not ordinary. It is a soft blue exception in a vast darkness. And now, we are drifting away from it. The moon rises ahead, gray and ancient, its surface covered in silent craters. There is no wind there, no rain, no clouds, no pink light. Only dust, rock, and the long memory of impacts. We pass it gently. Earth shrinks behind us. The moon shrinks too. Soon the two become a pair, one blue, one gray, floating together in the black. Then we move outward. Mars appears as a rusty ember, a dry, cold world with polar caps and dusty plains, still carrying the ghost of ancient rivers. Once, water may have moved across its surface. Once, its atmosphere may have been thicker. But now Mars is quiet, red and thin-aired, a planet of long shadows and frozen questions. We leave Mars behind. Beyond it lies the asteroid belt, a broad region of rocky fragments orbiting the Sun. They are not crowded like stones in a wall. Space is too wide for that. Most of the belt is emptiness, with lonely rocks moving through the dark on ancient paths. Then, far ahead, something enormous begins to appear. Jupiter, the first true giant. A world so large that it could hold more than 1,000 Earths inside it. Its bands of clouds stretch around the planet like painted rivers. Storms turn within storms. The great red spot, larger than Earth itself, has raged for centuries, a deep oval of wind and pressure and heat. Jupiter reminds us that not all planets are built like ours. Some worlds are not land and ocean. Some are atmosphere almost all the way down. Gas, pressure, storms, and hidden depths. Jupiter is our first familiar hint of what a giant planet can be. But even Jupiter, with all its size and mystery, is still part of our neighborhood. It is still warmed by the same sun. It still belongs to the same family. The pink planet does not. We continue outward. Saturn rises next, pale and golden, surrounded by rings so wide and thin they look almost impossible. From far away, Saturn seems calm, graceful, and weightless. Its rings are made of countless pieces of ice and rock, each one moving in orbit, each one reflecting sunlight back into space. We pass above the rings. For a moment, they stretch beneath us like a frozen ocean. Then they fade behind. Uranus appears, faint and blue-green, tipped strangely on its side, as if some ancient collision knocked it into a permanent lean. Neptune follows, darker, deeper, with winds faster than any hurricane on Earth. It is the last of the major planets, a cold blue world at the edge of the familiar map. And beyond Neptune, the Sun begins to feel different. It is still bright, still powerful, still the center of everything behind us. But it is smaller now, less like a sky, more like a star. This is one of the quietest moments in any journey through space, the moment when the Sun stops feeling like the Sun and begins to look like one star among many. Behind us, the planets are scattered along their orbits. The inner rocky worlds are too small to see. Jupiter and Saturn are tiny points. Neptune is almost lost. Earth has vanished completely, hidden inside the glare of the star that gave it life. Ahead of us lies interstellar space, the space between stars. Here, the distances stop feeling human. Miles no longer help us. Kilometers no longer help us. Even the distance from Earth to the Sun becomes a small unit, useful only inside our own solar system. To speak of GJ504b, we need a larger measure: light. Light is the fastest thing in the universe, and even light needs time. It can circle Earth several times in a single second. It can travel from the Moon to Earth in just over 1 second. It can cross the distance from the Sun to Earth in about 8 minutes. But to reach GJ504b's system, light needs about 57 years. It crossed empty space year after year, while seasons changed on Earth, while people were born, grew up, and grew older, while cities shifted, while technology changed, while telescopes became more powerful, while the James Webb Space Telescope itself was designed, built, launched, and unfolded in space. And finally, that faint light arrived. From Earth, GJ504 lies in the direction of the constellation Virgo. Virgo is not a destination in the way a city is a destination. It is a pattern we see from our viewpoint, a region of sky where stars at many different distances happen to appear near one another. But for ancient sky watchers, these patterns helped turn the night into a map. They gave names to darkness. They gave shape to the unknown. Somewhere in that direction is a star known as GJ504. It is similar to our Sun, though not identical. It is a star with its own light, its own gravity, its own history. Around it, far from the warmth and brightness of its center, circles the object we are traveling toward. GJ504b, the pink planet. But even saying that name makes it sound too simple. It is not a place we could land. It is not a world with trees or oceans or valleys. It is a giant companion, moving around its star at a great distance, far beyond the kind of orbit where Earth could exist. Around our own Sun, this would place it well beyond the orbit of Neptune, out in a region where sunlight is weak and shadows feel permanent. Imagine Jupiter moved far out into the dark, away from the warmth of the inner solar system. Then imagine that Jupiter was younger, hotter inside, still glowing faintly from its formation. Then imagine its light shifted into strange rose-colored tones. And imagine that, within its atmosphere, clouds rich in salt drift through the layers like pale mineral veils. That is the kind of world waiting ahead. As we travel, nothing seems to happen for a long time. This is another truth of space. Most of the universe is not crowded with drama. Most of it is distance, quiet distance, patient distance, the kind of distance that makes stars look fixed, even though they are moving, the kind of distance that turns giant worlds into points, the kind of distance that makes every discovery feel like listening to a whisper from across an ocean with no shore. For many years, GJ504b was only a faint companion beside a much brighter star. It was difficult to study because its star was so much brighter than it was. Looking for a dim planet near a star is often compared to trying to see a firefly next to a searchlight. The firefly may be there, glowing softly, but the glare around it overwhelms the eye. Astronomers needed patient instruments. They needed clever techniques. They needed to block or reduce the star's light enough to see what was hiding nearby. And when they did, they found something remarkable. A faint point of planetary light, a distant giant, a magenta world at the edge of visibility. Now, as our imagined spacecraft moves closer, the star GJ504 begins to brighten ahead of us. It is no longer just one point among many. It has become the center of a system. And far from it, separated by a wide, dark gap, another point glows weakly. At first it is almost nothing. A reddish speck, a soft ember, a rose-colored dot suspended beside a star. But as we approach, that dot slowly becomes round. The edges sharpen. The color deepens. The black space around it seems to grow even darker by contrast. This is the moment when a discovery stops being a number in a catalog and becomes a place in the mind, a real world, a giant object circling a real star. A body with gravity, temperature, chemistry, and clouds. The pink planet is no longer just a nickname. It is ahead of us now. Still distant, still silent, but waiting. And the closer we drift, the more one question begins to rise. What exactly are we looking at? Is this truly a planet like Jupiter, only farther away and stranger? Is it something larger, heavier, and closer to the border between planet and failed star? How did it form so far from its sun-like star? And what kind of atmosphere could wrap a world in pink light and salt-rich clouds? To answer that, we have to move closer, not only through space, but through the story of how this object was found. Because the pink planet did not reveal itself all at once. It began as a faint point beside a star. Then it became an image, then a mystery. And now, through the eyes of JWST, it has become a world with a sky we are only beginning to understand. As we drift closer to the faint rose-colored point beside GJ504, the name begins to feel too simple. The pink planet. It sounds almost gentle, almost like a place from a dream. But in astronomy, beautiful names often hide complicated realities. GJ504b is not a small, rocky planet like Earth. It is not a world with continents, oceans, beaches, forests, or blue skies. It is not a place where a spacecraft could land on solid ground and look around. It is a giant companion, a massive world-sized object circling a star beyond our solar system. And for many years, astronomers have placed it among the family of directly imaged exoplanets, rare worlds that have not merely revealed themselves through shadows or gravitational tugs, but through their own faint light. Most exoplanets are not seen directly. When astronomers discover planets around distant stars, they often do it by watching for tiny effects. Sometimes, a planet passes in front of its star, and the starlight dips by a very small amount. This is called the transit method. The planet itself may remain invisible, but its shadow gives it away. Sometimes, a planet pulls gently on its star, making the star wobble. This wobble can reveal the planet's presence, even when the planet cannot be seen. But direct imaging is different. Direct imaging means trying to see the planet itself, and that is extremely difficult. A star is bright. A planet is dim. The difference can be overwhelming. It is like trying to see a candle flame beside a lighthouse, or a firefly hovering near a stadium light. The planet may be there, quietly reflecting or emitting light, but the glare of its star can easily bury it. That is why directly imaged exoplanets are special. They are not just numbers in an orbit. They are faint points of real planetary light. And GJ504b is one of those rare objects. When it was announced, it stood out immediately. It was far from its star. It was relatively cool compared with many other directly imaged worlds, and it seemed to glow with a color that made people stop and imagine. A giant planet with the color of a dark cherry blossom. A dull magenta world in the deep sky. That image alone was enough to make it memorable. But GJ504b is more than a beautiful phrase. It is a scientific puzzle. To understand why, we have to think about what kind of object it is. In the simplest sense, GJ504b is a giant world orbiting a star called GJ504. That star is somewhat similar to our Sun, though not identical. It shines in the direction of the constellation Virgo, about 57 light-years away from Earth. Around that star, GJ504b moves on a wide orbit, much farther from its star than Earth is from the Sun. In our own solar system, Earth orbits close to the Sun compared with the outer giants. Jupiter is farther away. Saturn is farther still. Uranus and Neptune circle in the deep, cold outskirts. But GJ504b is separated from its star by an enormous distance, a distance that makes its existence especially interesting. Because the farther out you go in a young star system, the harder it can be to build a giant planet in the usual way. The common picture of giant planet formation begins inside a disk of gas and dust around a young star. Tiny particles collide and stick. Larger bodies form. Eventually, a solid core may grow massive enough to pull in huge amounts of gas, becoming a giant planet. But that process takes time, and far away from the star, where material is spread thinly across a wider region, building a giant planet can become more difficult. So when astronomers found a giant companion so far from GJ 504, the question was not only, what does it look like? The deeper question was, how did it get there? Did it form where we see it now? Did it begin closer to the star and move outward? Was it scattered by another massive object? Or did it form in a way more similar to a small star-like body, collapsing from gas directly rather than growing slowly like a planet? These are not small questions. They touch the boundary between planets and stars. And that boundary is not always as clean as it seems. A star is easy to recognize when it is large enough to ignite hydrogen fusion in its core. Our sun does this. It shines because deep inside it, hydrogen atoms are being fused into helium, releasing energy that travels outward as light and heat. A planet does not do this. Jupiter is massive, Saturn is massive, but they are not stars. They do not burn with steady fusion. They are worlds, not suns. But between giant planets and true stars, there is a strange middle category. Brown dwarfs. A brown dwarf is often described as something too massive to be an ordinary planet, but not massive enough to live as a true star. It may briefly burn certain heavier forms of hydrogen, depending on its mass, but it never becomes a stable, shining star like the sun. It is sometimes called a failed star, though even that phrase is a little unfair. A brown dwarf is not a failure. It is its own kind of object, a dim ember in the universe, a body caught between categories. And this is where GJ 504b becomes especially fascinating. For a long time, it was widely discussed as a giant planet, one of the coldest and most intriguing worlds ever directly imaged. But newer analysis from JWST suggests that it may be much heavier than some early estimates. Heavy enough that the line between planet and brown dwarf becomes less comfortable. So what is it? A planet? A brown dwarf? Something in between? The honest answer is that GJ 504b lives in a borderland. And that borderland is part of what makes it beautiful. Human beings like clear categories. We like names, boxes, and definitions. We like to say, this is a planet, this is a star, this is a moon, this is a cloud, this is weather. But the universe does not always care about our categories. It makes objects first. Then we try to name them. GJ 504b is a perfect example. It is massive enough to challenge simple labels. It is distant enough to challenge formation models. It is dim enough to challenge our instruments. And now, with JWST, it has revealed an atmosphere strange enough to challenge our imagination. That atmosphere is one of the main reasons scientists are so interested in it. Because unlike a rocky planet, where we might hope to find a surface, GJ 504b is a world of depth. Its story is written in layers of gas and cloud. There may be no clear boundary where sky ends and ground begins. If you descended into it, you might pass through haze, then cloud, then deeper gas, then higher pressure, then hotter layers, and still never reach anything like a landscape. It is less like falling toward a planet, more like falling into an endless sky. And that sky is not empty. It contains molecules, water vapor, methane, carbon dioxide, ammonia, other chemical fingerprints hidden in infrared light. These are not molecules arranged into oceans or forests or breath. They are part of an alien atmosphere, shaped by temperature, pressure, gravity, and time. And above or within those layers, there may be clouds rich in salt. This is where the pink planet becomes more than a distant object. It becomes a place with weather. not whether we could stand beneath. Not rain tapping on windows, not thunder rolling over mountains, but atmospheric behavior all the same. Particles forming, cloud layers drifting, chemistry rising and sinking, light escaping from some depths and being blocked from others. A giant world breathing heat into space. When we look at GJ504b, we are not just seeing a pink dot beside a star. We are seeing the outer glow of a hidden atmosphere. We are seeing an object that formed billions of years ago and has been cooling ever since. We are seeing a world that may not fit perfectly into any simple definition, and that may be the most honest way to understand it. GJ504b is not important because it is easy to classify. It is important because it is not. It reminds us that the universe is not built from textbook diagrams. It is built from real objects, with messy histories and complex atmospheres, moving through real space. Some are clearly planets. Some are clearly stars. Some are moons, asteroids, comets, or icy bodies. And some, like this dim pink companion, wait quietly between the names. So as we drift closer, we should not imagine the pink planet as a simple place. We should imagine it as a mystery with gravity, a massive companion circling a sun-like star, a world or near world still glowing from its past, a body with a pinkish atmosphere, a wide orbit, and a sky that may hold clouds of salt. It does not ask to be understood quickly. It asks us to slow down, to look again, to let its light pass through the instruments of JWST and return to us as a story. And that story is only beginning. Because now that we have asked what the pink planet is, the next question becomes even more dreamlike. Why does it look pink at all? What could give a giant world, floating in deep space, the color of a faded blossom in the dark? Why would a world look pink? It is a simple question at first, almost childlike. But in space, simple questions often open into deep ones. On Earth, color feels familiar because light feels familiar. We know the blue of the sky, the green of forests, the white of clouds, the orange of sunset, the silver of moonlight on water. We know colors because we live inside them every day. But the color of a distant planet is not always like the color of an object in your hand. It is not like looking at a painted stone. It is not like standing beside a flower. It is light after a long journey. Light shaped by temperature. Light filtered by atmosphere. Light changed by clouds, molecules, haze, and distance. When astronomers speak of the pink planet, they are not saying that this world is a simple, bright, cartoon-like pink sphere floating in space. The reality is quieter, stranger, and more beautiful than that. GJ504b is often imagined as a world with the color of a dark cherry blossom, a dull magenta, a rose-like ember, a soft, faded glow coming from a giant body still releasing the heat of its formation. It is not pink because someone painted it pink. It is pink because physics has given it a strange kind of light. To understand that, imagine a world being born. Not born in one moment, but assembled over time inside the young disk of material surrounding a star. Gas and dust swirl together. Gravity pulls. Matter gathers. A growing body becomes heavier and heavier, drawing more gas into itself, compressing under its own weight. A giant planet, or a giant planet-like companion, does not form quietly. It forms with energy, with heat, with pressure, with collision, collapse, and gravitational violence hidden inside the calm shape we eventually see from far away. And after such an object forms, it does not instantly become cold. It cools slowly, very slowly. Over millions and billions of years, heat leaks out from within. The world glows faintly, not because it is a star, but because it still remembers the heat of its beginning. That is one of the most poetic truths in planetary science. Some worlds shine with the memory of their birth. GJ504b is one of them. It does not blaze like a sun. It does not fill space with warm daylight. But in infrared light, the kind of light our eyes cannot see directly, it glows. And when that glow is translated into something we can imagine, it becomes a strange, muted pink. A dark blossom in the sky. A cooling ember wrapped in atmosphere. But color is never only about heat. Atmosphere matters. On Earth, the sky is blue because molecules in the air scatter blue light more strongly than red light. At sunset, sunlight passes through more atmosphere, and the colors shift toward orange and red. Clouds appear white because tiny droplets scatter many colors together. The ocean looks blue because of how water absorbs and reflects light. Color is not just decoration. Color is a story of interaction. Light meets matter. Matter changes light. And the changed light reaches our eyes. On GJ504b, the same basic idea applies, but with a completely different cast of characters. There is no blue sky like ours, no oxygen-rich air, no ocean surface reflecting daylight. Instead, there is a deep atmosphere made mostly of gases common to giant worlds, with molecules that absorb and release light in their own ways. Methane, water vapor, carbon dioxide, ammonia, other chemical traces hidden in the infrared, and clouds, possibly salt-rich clouds. Each of these can change what the planet looks like. Each can remove certain wavelengths of light and allow others to escape. Each can make the world appear dimmer, redder, darker, warmer, colder, smoother, or more mysterious. This is why the color of the pink planet is not merely a visual detail. It is a clue. A distant clue, yes. A faint clue, yes. But still a clue. When we say this world appears dull magenta, we are really saying that the light leaving its atmosphere carries the imprint of heat and chemistry. We are saying that the planet's outer layers are shaping what reaches us. We are saying that its sky, though impossible for us to enter, is still speaking. Not in words, in wavelengths. Imagine hovering far above GJ504b. The star is far away, much smaller than our sun appears from Earth. Its light touches the upper atmosphere weakly compared with the sunlight we know. Around you is silence. Below you is the enormous curve of the planet, filling more and more of the view. The color is subtle, not bright, not cheerful, not warm in the human sense. It is a smoky pink, mixed with brown, violet, gray, and shadow. A color that seems to belong to twilight, but there is no Earth-like sunset here. No horizon of land, no ocean line, only atmosphere bending into darkness. As the planet rotates, the color may not be perfectly even. Some regions may be darker, some may be veiled by clouds, some may glow slightly differently, depending on temperature, cloud thickness, or the depth of the atmosphere you are seeing. The pink planet may not look like one smooth marble. It may look layered, soft, stormy in a slow, giant world way, a face of gas and cloud, with subtle changes moving across it over time. And if the salt clouds are present, they may act like curtains. Not solid curtains, but atmospheric veils. They can hide warmer layers below. They can soften the signatures of molecules deeper down. They can make the planet's light less direct, more filtered, more mysterious. In that sense, the pink color and the salt clouds are connected in a beautiful way. The color draws us in. The clouds explain why the light is difficult. The atmosphere turns a distant point into a mystery. Here on Earth, pink often feels delicate. A flower, a dawn sky, a shell, a soft reflection on water. But on GJ504b, pink belongs to something enormous, something massive, something without a surface, something cold compared with the hottest young exoplanets, yet still warm enough inside to glow beyond the reach of ordinary human sight. It is pink, not because it is gentle, but because it is ancient, cooling, and wrapped in chemistry. That contrast is what makes it so haunting. The color invites us closer. The science reminds us we could never stand there. There is no meadow under that pink sky, no quiet beach, no breathable air, no ground where a shadow could fall. Only gas, pressure, cloud, heat, molecular absorption, and a glow that has crossed 57 years of darkness to become a faint signal in our telescopes. If Earth is blue because of air and water, and Mars is red because of iron-rich dust, then GJ504b is pink because of something deeper and less familiar. It is a color born from a giant atmosphere, from leftover heat, from infrared light, from molecules and clouds interacting in ways that do not happen in our sky. And that is why this world feels less like a simple planet and more like a dream the universe had while cooling down. A giant magenta atmosphere. A dark cherry blossom in orbit around a distant star. A world that glows softly, not for us, but because physics has left a fading ember inside it. Still, the color was only the beginning. For years, it made GJ504b famous. It gave the world its nickname. It made people imagine a strange pink giant floating in the black. But color can only tell us so much. To learn what was actually in the atmosphere, astronomers needed more than an image. They needed to take the light apart. They needed to listen to it carefully. And that is where the James Webb Space Telescope enters the story. Because JWST did not simply look at the pink planet. It read its light like a message. To understand the pink planet, we cannot travel there. Not yet. Maybe not for thousands of years. 57 light-years is too far for any spacecraft we have ever built. Even our fastest probes would need an unimaginable span of time to cross such a distance. Human lifetimes rise and fall too quickly for that kind of journey. Civilizations change. Languages change. Entire histories pass. And still, the distance remains. So astronomy has learned a different kind of travel. It travels through light. A telescope is not only a machine for seeing, it is also a machine for listening, if we understand listening in a quiet, cosmic way. It listens to photons. It listens to wavelengths. It listens to tiny changes in brightness, color, and pattern. And from those changes, it reconstructs worlds. This is how the James Webb Space Telescope approaches GJ504b. JWST does not fly toward the pink planet. It does not pass over its clouds. It does not drop a probe into its atmosphere or send back a close-up image of salt particles drifting through alien air. It stays near Earth, far from the heat and glare of our own planet, shielded from the sun, carefully cooled, patiently pointed into the dark. And from there, it waits for light. The light from GJ504b is faint, almost impossibly faint. The planet, or planetary mass companion, is much dimmer than its star. Its glow is weak, soft, and easy to lose in the surrounding brightness. For older instruments, studying it in detail was extremely difficult. Astronomers could detect it. They could measure some of its light. They could begin to understand its color and temperature. But the atmosphere remained like a closed book. JWST changed that. With its large golden mirror and sensitive infrared instruments, JWST can collect kinds of light that human eyes will never see directly. Infrared light is the light of warmth, the light of cooling worlds, the light that can carry information from dim objects that do not shine like stars. For a world like GJ504b, this is essential. The pink planet is not bright invisible light the way a lamp is bright. It is not reflecting strong sunlight from nearby. It is a faint infrared presence, a body still releasing internal heat into space. So JWST does what it was built to do. It gathers that infrared glow, Then it separates the light. This is where the story becomes almost magical. When light is split into a spectrum, it becomes more than brightness. It becomes a fingerprint. Imagine holding a beam of light and spreading it out into many fine colors. Not only the colors our eyes can see, but also invisible infrared shades beyond red. Across that spread of light, certain wavelengths are weaker than others. Some are missing. Some are absorbed. Some carry the marks of molecules that the light has encountered. Every molecule has its own way of interacting with light. Water vapor absorbs certain wavelengths. Methane absorbs others. Carbon dioxide has its own signature. Ammonia leaves its own trace. The atmosphere does not write its name in letters. It writes in patterns. And JWST can read those patterns. This is why a spectrum can be more powerful than a picture. A picture shows us where something is. A spectrum begins to tell us what it is made of. For GJ504b, JWST's light carried hints of a complex atmosphere. The data suggested the presence of familiar molecules in an unfamiliar place. Water vapor, methane, carbon dioxide, ammonia, and other chemical signs shaped by the temperature and pressure of a giant world. These names may sound ordinary at first. Water, methane, carbon dioxide, ammonia. We know these words from Earth, from laboratories, from weather, biology, and chemistry. But on GJ504b, they do not mean Earth-like life. They do not mean lakes or breathing air. They are part of a giant atmosphere, moving under crushing gravity and strange temperatures, far from the surface conditions we know. Water vapor there is not the water cycle of Earth. Methane there is not a simple sign of cows, swamps, or life. Carbon dioxide there is not a climate story like ours. Ammonia there is not a household chemical. On the pink planet, these molecules are ingredients in an alien sky. A sky with no ground beneath it. A sky so deep that descending into it would be like sinking into a world made entirely of weather. And yet, even with these molecules identified, the story was not complete. When scientists tried to model the atmosphere, the light did not fully make sense. This is an important part of the process. Astronomers do not simply look at a spectrum and instantly know the answer. They build models. They test combinations of gases, temperatures, pressures, clouds, and chemical abundances. They ask, what kind of atmosphere could produce this exact pattern of light? It is like hearing a few notes from a distant instrument and trying to reconstruct the entire song. Sometimes, the first model does not fit. Sometimes, the molecules are not enough. Something else must be shaping the light. For GJ504b, that missing piece appeared to be clouds. Clouds can hide. Clouds can soften. Clouds can flatten features in a spectrum. They can block light from deeper, warmer layers and make the atmosphere appear different from what it would look like if it were clear. On Earth, we know this intuitively. A cloudy day changes everything. The sunlight becomes softer. Shadows disappear. Colors flatten. The sky no longer tells the same story it tells on a clear afternoon. On a giant exoplanet, clouds do something similar, but in a far more exotic way. They change the outgoing light. They decide which layers we can see and which layers remain hidden. And in the case of the pink planet, the best explanation was not ordinary water clouds, not Earth-like clouds, not the soft white shapes we know from our own sky. The models pointed toward salt-rich clouds, tiny particles of salt-bearing material, suspended high in the atmosphere, veiling the deeper layers below. This is the moment when the pink planet becomes even stranger. Because the telescope did not see a cloud in the way our eyes see a cloud. It did not photograph a white patch drifting across a pink sky. Instead, JWST saw the effect of clouds on light. It saw the atmosphere behaving as if something cloudy was there. And when scientists asked what kind of cloud made the most sense, Salt clouds gave the most natural answer. That is a quiet kind of discovery. There is no explosion, no dramatic image, no spacecraft descending through mist. Only a line of light, spread into a spectrum, carrying small differences that reveal a hidden sky. And yet, those small differences tell us something extraordinary. Somewhere around a star 57 light-years away, a giant pink companion may be wrapped in mineral clouds. Its weather may be written not in oceans and rain, but in salt particles drifting through hydrogen-rich air. Its atmosphere may be layered like a veil, hiding and revealing different molecular signatures depending on depth. And all of this reached us as faint infrared light. That is the wonder of JWST. It does not need to touch a planet to begin knowing its clouds. It does not need to enter the atmosphere to sense what is floating there. It can sit in darkness near our own world and read a message that began its journey decades ago. A message from a pink giant. A message from a place without a surface. A message from a sky made of gases, heat, and salt-rich haze. There is something deeply peaceful about that. The universe does not speak loudly. Most of the time, it whispers. A star dims by a fraction. A spectrum dips at one wavelength. A faint companion glows beside a brighter star. A model fails, then fits, once a hidden layer is added. And slowly, patiently, a world becomes more real. GJ504b was once only a distant point. Then it became the pink planet. Now, through JWST, it has become something richer. A world with chemistry, clouds, and a strange atmosphere that refuses to be simple. And as we drift closer in our imagination, we begin to understand that the true beauty of this world is not only its color. It is the fact that its light carries a memory of heat, a memory of formation, a memory of molecules rising and sinking in a deep atmosphere, a memory of clouds made from something we would never expect to find floating in a sky. The telescope has read the light has revealed the clouds, and the clouds lead us into the strangest part of the journey. Because now we must ask what it really means for a planet's weather to be made of salt. Clouds made of salt. The phrase sounds almost impossible. It feels like something from a dream, or from an old myth about distant worlds no one could ever visit. On Earth, salt belongs to oceans. It belongs to waves breaking against shorelines, to white crystals left behind when seawater dries, to the taste of the sea carried by wind. Salt is something we hold in our hands, something we sprinkle over food, something dissolved in water, hidden inside the blue immensity of our planet's oceans. But on GJ504b, salt may belong to the sky, not as falling grains, not as the kind of salt we see on a table, but as tiny particles suspended in a deep atmosphere, forming clouds far from any ocean, far from any beach, far from anything we would recognize as a surface. This is one of the most beautiful and unsettling ideas in planetary science. The same universe that gives Earth white clouds of water can give another world clouds made from minerals. The sky is not always made from what we expect. A cloud is simply a collection of tiny particles, or droplets, floating in an atmosphere. On Earth, those particles are usually water droplets or ice crystals, because our planet has the right temperatures, pressures, and chemistry for water to move between ocean, vapor, cloud, rain, snow, and ice. Our weather is built around water. Water rises. Water cools. Water condenses. Water falls. And because we have lived under this cycle for all of human history, we think of clouds as soft, white, and familiar. But the universe does not use only one recipe. Change the temperature, and different materials can condense. Change the pressure, and different clouds can form. Change the atmosphere, and the sky itself becomes a different kind of laboratory. On Jupiter, clouds can contain ammonia. On Saturn, layers of haze and ice shape the planet's golden bands. On very hot exoplanets, where temperatures can reach extremes beyond anything on Earth's surface, clouds may be formed from silicates, materials more similar to rock than rain. Some worlds may even have skies where metals and minerals behave in ways that feel impossible to us, because their atmospheres are nothing like ours. So when astronomers studied the light of the pink planet, and the models suggested salt-rich clouds, they were not saying that a familiar Earth cloud had been sprinkled with seasoning. They were saying something stranger. They were saying that in the atmosphere of this distant giant, the chemistry and temperature may allow salt-bearing compounds to condense into tiny particles, forming cloudy layers that affect the light escaping from the planet. A mineral veil, a salty haze, a cloud deck made from substances that, on Earth, we usually associate with oceans, rocks, or crystals. Imagine drifting above GJ504b now. The planet is enormous beneath you. Its color is not uniform. It is a muted pink, deep and smoky, with darker regions where the atmosphere is thicker, and brighter regions where heat or thinner cloud layers allow more light to escape. You cannot hear anything. Space around you is silent. The star GJ504 shines far away, bright but small, unable to make this world feel like home. Below, the atmosphere turns slowly. There are no continents to mark rotation, no blue oceans, no green land, no white polar caps, only layers, pink and gray, rose and brown, magenta and shadow. And somewhere within those layers, the salt clouds drift. They may not look bright white like the clouds above Earth. They may not form puffy shapes with clear edges. They may be diffuse, subtle, and deep, more like fog spread through a vast giant atmosphere than cotton-like clouds floating over a landscape. They may wrap around the planet in bands. They may thicken in some regions and thin in others. They may hide the warmer layers below, changing the spectrum that JWST reads from far away. This is why clouds are so important. Clouds are not just decoration. They are filters. They are curtains. They decide what light can escape. If the atmosphere were perfectly clear, JWST would see deeper into the planet's warm layers. The molecular fingerprints would appear in one way. But if a cloud layer sits above those deeper regions, the light changes. Some signals become weaker. Some features are softened. The atmosphere looks different. That is what seems to have happened with GJ504b. The molecules alone did not tell the full story. The light seemed to need something else, something suspended in the atmosphere, something that could mute the deeper signatures and make the model more physically believable. And the most natural answer was salt clouds. It is important to pause here, because this kind of discovery is subtle. No one has flown into GJ504b's atmosphere and collected a sample. No probe has passed through its clouds. No camera has photographed a close-up of a salty storm. The evidence comes from light, from spectrum, from modeling, from the way different atmospheric ingredients produce different patterns. This is how distant worlds reveal themselves. Not all at once. Not with certainty in every detail, but slowly, through clues that become stronger when they fit together. JWST sees the light. Scientists build models. The models ask, what atmosphere could create this light? And when salt-rich clouds are added, the story becomes more coherent. That is enough to make the pink planet feel suddenly more real. Because now, when we imagine it, we are not imagining only a color. We are imagining a sky. A deep, layered, alien sky. A sky where water is not the main artist. A sky where minerals can float. A sky where salt, something so ordinary on Earth, becomes part of a giant world's weather. There is something strangely calming about that thought. Salt is familiar. Clouds are familiar. But together, in this place, they become completely unfamiliar. This is what the universe does so well. It takes ingredients we know and rearranges them under conditions we do not know. It turns water into ice on one world, methane into lakes on another, ammonia into clouds on a gas giant, silicates into hazes above planets hotter than fire, and salt into clouds around a distant pink companion. The same elements and compounds can live many different lives. Here, salt belongs to oceans. There, it may belong to the atmosphere. Here, clouds bring rain. There, clouds may only drift endlessly through a world without ground. Here, weather is part of the rhythm of life. There, weather may be a silent process inside a giant body no living thing has ever touched. If you were somehow descending into JJ504b, the experience would not be like falling through the sky of Earth. At first, there would be the upper haze, thin and faint, with the blackness of space above you and the pink glow below. Then the atmosphere would grow thicker. The colors would deepen. The outside light would dim. The salt-rich particles might scatter the glow into a soft mineral mist around you. There would be no horizon, only a gradual fading of distance, as if the world were made of fog and pressure. Downward, the gas would become denser. The pressure would rise. The temperature would change. The molecules would shift. Methane, water vapor, carbon dioxide, ammonia, each present in its own balance, each shaping the invisible chemistry around you. And still, there might be no surface, no place to land, no final moment where the clouds break and reveal ground. Only deeper layers, a sky becoming heavier and heavier, until the word sky no longer feels right. That is the nature of a giant world. It is not a planet in the Earth-like sense. It is a vast atmosphere surrounding an enormous mass. And in that atmosphere, clouds are not weather above a world. They are part of the world itself. This makes the salt clouds of JJ504b especially meaningful. They remind us that weather does not require a surface. It does not require oceans. It does not require trees bending in wind or rain falling on rooftops. Weather is what happens when atmosphere, temperature, pressure, and chemistry interact. On Earth, that interaction creates storms, snow, monsoons, clouds, and lightning. On the pink planet, it may create drifting salt-rich layers wrapped around a glowing magenta giant in the dark. The image is quiet, but enormous. A world with no shore, no sea, no land, and still, somehow, salt in the clouds. If we could watch it for long enough, perhaps we would see changes. Cloud bands slowly shifting, haze thickening and thinning, regions of the atmosphere rotating in and out of view, brightness subtly rising and falling as deeper heat escapes through thinner places. But we are far away. We see only the faint light. And that faint light is enough to tell us that the atmosphere is not simple. It is layered. It is cloudy. It is chemically rich. It is a place where the familiar rules of Earth no longer hold. That is the real wonder of JJ504b. It does not have to be habitable to be fascinating. It does not have to be Earth-like to matter. It does not need oceans, continents, or life to teach us something profound. It teaches us that the universe makes weather in many languages. Water clouds are only one sentence. Earth's rain is only one melody. Beyond our solar system, there may be skies of minerals, hazes of metal, clouds of ammonia, storms of silicate dust, and soft salt veils wrapped around giant pink worlds. And each one is real in its own way. Each one is a reminder that the sky above us is not the only kind of sky that can exist. So as we hover above the pink planet, looking down into its rose-colored depths, we can let the idea settle quietly. Somewhere, 57 light-years from Earth, a massive companion circles its star. It glows faintly with leftover heat. Its atmosphere carries the fingerprints of molecules we can recognize, but in a place we cannot imagine fully. And hidden in that atmosphere, shaping the light, there may be clouds rich in salt. Not the salt of a human kitchen, not the salt of an ocean wave, but the salt of an alien sky. The pink planet was already strange because of its color. But now, with JWST's light, it becomes something even more beautiful. A world where weather is mineral. A world where clouds are not white. A world where salt drifts in silence above a bottomless atmosphere. And as we continue deeper into this journey, we begin to understand that those salt clouds are only one part of a larger mystery. Because a cloud does not exist alone. It belongs to weather. It belongs to movement. It belongs to temperature, pressure, wind, and time. So the next question is not only what the clouds are made of. The next question is, what kind of weather could exist on a cold giant like this? To understand the weather of GJ504b, we have to forget almost everything we know about weather on Earth. Here, weather feels close to us. It arrives at our windows. It moves through our streets. It changes the color of the morning. A storm begins as dark clouds over the horizon. Rain taps against rooftops. Wind bends trees. Snow covers fields. Fog softens the edges of buildings. Thunder rolls across the sky and disappears beyond the hills. Earth's weather is intimate. It touches skin. It gathers above land and sea. It belongs to a planet with a surface. But on the pink planet, there may be no surface at all. No ground. No shoreline. No mountains to catch the wind. No oceans to feed familiar clouds. No forests to wait beneath the rain. Only atmosphere. A vast atmosphere wrapped around a giant mass, growing denser and deeper the farther down you go. On a world like this, weather does not happen above the planet. Weather is the planet. It is the outer face of the world, the visible skin of a body made of gas, pressure, heat, cloud, and chemistry. This is one of the hardest ideas to imagine, because we are surface creatures. We measure planets by where we could stand. We imagine landscapes. We imagine horizons. We imagine looking out from a solid place into a sky above us. But a gas giant changes the meaning of sky. If you could descend into GJ504b, there may never be a moment when sky ends and land begins. There may only be gradual change. Thin gas becoming thicker, haze becoming cloud, cloud becoming deeper atmosphere, pressure rising, temperature shifting, light fading. Downward would not lead to a landscape. It would lead to more depth. The pink planet is often described as cold compared with many young giant exoplanets that have been directly imaged. But cold is a relative word in astronomy. To us, this world may still be hot by human standards, glowing in infrared light, carrying internal heat from its formation. It is cold the way a cooling ember is cold compared with a flame. Not comfortable, not gentle, just quieter, older, less violently bright. A world still warm inside, but dim enough to hide many of its secrets. That inner heat matters, because on a giant planet, heat does not only come from the star. The star is far away. Its light reaches GJ504b, but weakly compared with the sunlight Earth receives. This world is not basking close to its sun. It is distant, set apart, moving through a colder region of its system. But from inside, heat still rises. Slowly, quietly, over immense periods of time. That heat moves upward through the atmosphere. It interacts with gas. It shapes circulation. It affects what condenses, what evaporates, what sinks, and what remains suspended. Weather on a giant world can be driven from below as much as from above. On Earth, the sun warms the surface. Warm air rises. Water evaporates. Clouds form. Winds move heat around the globe. On GJ504b, there is no Earth-like surface receiving sunlight. Instead, the atmosphere may be stirred by deep internal warmth, rotation, gravity, and chemistry. The result may be a weather system, unlike anything we have seen up close. Imagine a world covered entirely in moving air. A world where every visible feature is a cloud or haze. A world whose surface is simply the level where the atmosphere becomes thick enough to block your view. From far away, you might see bands. Not exactly like Jupiter's, but perhaps something similar in principle. Regions where air moves in different directions, where cloud layers form at different heights, where chemistry and temperature create subtle changes in brightness. Some parts of the planet may appear darker because thicker clouds hide warmer layers below. Some parts may glow more strongly in infrared, where deeper heat escapes through thinner regions. Some areas may carry more methane absorption. Others may show signs of cloud opacity. The whole visible face of the planet might be a slow conversation between heat trying to escape and clouds trying to conceal it. This is the quiet drama of giant planet weather. Not rain falling on soil, not lightning over a city, but energy moving through depth, a world cooling itself through its atmosphere, a vast body releasing the memory of its birth, one faint photon at a time. And within that process, salt clouds may form. The salt-rich particles are not floating in an empty sky. They are part of a system. They appear where the temperature and pressure allow certain compounds to condense. Too hot, and the material may remain vapor. Too cold, and it may settle deeper or form different layers. Just right, and tiny particles can gather into haze or cloud. This means the clouds are like markers. They tell us about the hidden structure of the atmosphere. They tell us that somewhere in the upper or middle layers of this giant world, conditions may allow salt-bearing material to become visible as cloud. A cloud is not just a cloud. It is a thermometer, a pressure gauge, a chemical clue, a signpost in a place we cannot enter. If we could hover beside the planet for years, perhaps we would see the clouds change slowly. A broad pink-gray band shifting across the disk. A darker patch rotating into view. A cloudy region thickening, then thinning. A bright infrared window opening briefly, then closing again as haze moves across it. There might be storms, though not storms in the way we picture them. No rain falling on streets, no waves rising in an ocean, no lightning necessarily visible to our eyes. Instead, storms could be deep atmospheric disturbances, enormous rising columns of warmer gas, cloud systems larger than Earth, or rotating regions where chemistry changes with height. On a giant planet, a storm can be a continent-sized pattern in the atmosphere. A moving structure with no land beneath it. A weather system floating over nothing but more weather. That thought is both strange and peaceful. It means GJ504b may be alive with motion, but not the kind of motion that feels urgent to us. Its weather may be slow, massive, layered. The turning of a giant, not the flicker of a small world. A cloud system there might last for months, years, or much longer. Winds could move through vast pressure layers. Heat could rise from depths we cannot see. Molecules could be carried upward, altered by temperature, then hidden again beneath clouds. The planet's atmosphere may be like an ocean without a surface, except the ocean is gas, and the waves are pressure, and the currents are invisible streams of heat and chemistry. To us, weather often means change, from one day to the next. On GJ504b, weather may be measured by rotation, by deep circulation, by gradual cooling, by the slow rearrangement of clouds across an entire world. And because this world is far from its star, its weather may feel especially isolated. There is no warm sun high overhead, no bright noon, no blue afternoon. The star is distant. The sky, if we could call it a sky, would not be lit like Earth's. Much of the visible drama may come from the planet's own glow, especially in infrared, heat rising from within and escaping through layers of atmosphere. Imagine being inside that glow, not seeing sunlight fall from above, but sensing warmth coming from below. Not watching the sky brighten with dawn, but seeing the atmosphere softly illuminated by the world itself. The pink planet may be less like a planet under a sun, and more like a dim lantern wrapped in clouds. A lantern made of gas. A lantern cooling in space. A lantern with salt in its veil. This is why the phrase, cold giant, feels so powerful. It combines opposites. Cold, but glowing. Distant, but warm inside. Beautiful, but inhospitable. Quiet, but filled with motion. Pink, but massive. Cloudy, but without oceans. It is not a place for life as we know it, but it is a place for physics. A place for atmosphere. A place for chemistry to become weather. And that is enough to make it meaningful. Because when we study GJ504b, we are not looking for a second Earth. We are learning how wide the category of world can be. We are learning that weather does not need to look like rain. Clouds do not need to be water. A planet does not need a surface to have character. The pink planet has character because its atmosphere is complex, because its light is shaped by molecules and clouds, because it forces us to imagine weather without ground. And as we drift beside it, slowly circling above its upper layers, we can let that idea become quiet and clear. Below us is not a landscape. It is not a desert, or a sea, or a frozen plain. Below us is a sky so deep it becomes a world. A sky where salt may drift. A sky where heat rises from ancient depths. A sky where clouds hide the layers below. A sky whose color is a smoky pink, fading into shadow at the limb of the planet. There is no place to stand, no place to arrive. Only atmosphere, continuing downward beyond sight. And somewhere inside that atmosphere, the weather of GJ504b moves in silence. Slowly. Patiently. Far from Earth. Far from the sun. Far from everything familiar. The pink planet turns in the dark, wrapped in clouds that may be made of salt, releasing the last warmth of its beginning into space. But even now, another mystery waits behind the clouds. Because the more we learn about this object, the harder it becomes to place it neatly into one category. It is called a planet. It looks like a planet in our imagination. It orbits a star, glows softly, and carries an atmosphere. And yet, it may be massive enough to stand near a strange boundary. The boundary between planet and something almost like a star. At first, the pink planet feels easy to imagine. A giant world, a distant orbit, a soft magenta glow, clouds rich in salt. It moves around a star, so naturally, we call it a planet. That word feels comfortable. Planet, a world, a body that belongs to a star. Something like Earth, Mars, Jupiter, or Neptune, only stranger and farther away. But the more closely astronomers study GJ504b, the less comfortable that simple word becomes. Because this object does not sit neatly inside our expectations. It is massive. It is distant. It is dim, but still glowing. It has an atmosphere that can be studied like the atmosphere of a giant planet. And yet, it may be heavy enough to live near one of the most fascinating borders in astronomy, the border between a planet and a brown dwarf. To understand why that matters, we have to step back and ask a very basic question. What makes a planet a planet? It sounds simple, but it is not. In our solar system, the answer feels easier because the objects are familiar. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune all orbit the Sun. They are not stars. They do not shine by stable nuclear fusion. They are much smaller than the Sun, and they belong to the architecture of our solar system. Jupiter is the largest planet we know nearby. It is enormous. It has storms larger than Earth. It has powerful magnetic fields, dozens of moons, and a deep atmosphere with no familiar surface. But Jupiter is still clearly a planet. It is massive, but not massive enough to become a star. Our Sun, by contrast, is completely different. The Sun is not merely a glowing ball of gas because it is hot. It shines because deep inside its core, gravity has squeezed hydrogen to such extreme temperatures and pressures that nuclear fusion can happen. Hydrogen becomes helium, energy is released, light and heat pour outward, and that steady fusion is what makes the Sun a true star. A planet does not do this. A planet may be warm. A planet may glow in infrared. A young giant planet may still radiate heat from its formation, but it does not ignite like a star. Between these two familiar categories, however, lies something strange. A brown dwarf. A brown dwarf is often described as a failed star, but that phrase is only partly useful. It suggests that the object tried to become a star and did not succeed. But nature does not really fail. It simply makes what gravity and matter allow it to make. A brown dwarf is a body more massive than a typical giant planet, but not massive enough to sustain the kind of stable hydrogen fusion that powers stars like the Sun. It is too small to be a true star, too large to feel like an ordinary planet. It glows faintly, cools over time, and slowly fades into darkness. In a way, a brown dwarf is like a cosmic ember, not a campfire, not a cold stone, something in between, warm from its birth, dim in the dark, a body that carries heat, gravity, and atmosphere, but never becomes a sun. And this is where GJ504b becomes complicated. Early discussions of the pink planet often treated it as a giant exoplanet, perhaps only a few times the mass of Jupiter. A large world, yes, but still comfortably within the range of planets. But newer work has suggested it may be much heavier. Possibly heavy enough that astronomers have to be more careful. If its mass is high enough, then GJ504b may not be a simple Jupiter-like planet. It may belong closer to the world of brown dwarfs, or at least near the boundary where the difference becomes difficult to define. This does not make it less interesting. It makes it more interesting, because boundaries are where science often becomes most alive. A clearly Earth-like planet is easy to name. A clearly Sun-like star is easy to name. But an object between categories forces us to ask better questions. Did it form like a planet? Did it form like a small star? Did it grow inside a disk of gas and dust around its star, gradually building itself like other planets? Or did it collapse more directly from gas, like a tiny stellar object that never gained enough mass to shine? These formation questions may matter even more than the label, because sometimes the difference between a giant planet and a brown dwarf is not only mass. It is history. A giant planet may form inside the disk around a young star, starting with a core and gathering gas. A brown dwarf may form more like a star, from the collapse of a region of gas under gravity. But nature may not always keep those processes separate. There may be objects formed one way that look like objects from the other category. There may be worlds that blur the line. GJ504b may be one of them. It circles a star, like a planet. It has an atmosphere, like a giant planet. It glows from leftover heat, like a young or massive gas giant. But it may also be heavy enough to make astronomers hesitate. And this hesitation is not a weakness in science. It is honesty. Science is not the art of forcing the universe into simple names. It is the art of letting the universe be as strange as it is, then building better language around it. The pink planet is beautiful, partly because it resists being simplified. It asks us to live with uncertainty. It asks us to imagine a world that may be a planet, or may be something close to a failed star, or may be best described as a planetary mass companion. That phrase sounds less poetic. Planetary mass companion. It does not have the same magic as pink planet. But it may be more careful. It means an object with a mass in the broad range of planets, orbiting or accompanying a star, without forcing us to decide too quickly exactly how it formed. And perhaps that is the best way to hold GJ504b in the mind. Not as one simple thing, but as a mystery with layers. Its outer layer is the image, a dull magenta world glowing in the dark. Below that is the atmosphere, methane, water vapor, carbon dioxide, ammonia, and other molecules shaping the light. Below that are the clouds, salt-rich particles forming strange veils in the sky. Below that is the question of heat, the leftover energy from formation still leaking outward. And below that is the deepest question of all. Origin. How did this object come to be? If GJ504b formed like a planet, then it challenges us to explain how such a massive giant could form so far from its star. Far from the star, material in the disk is spread thin. Building a giant body there can be slow and difficult. The usual planet-building process may struggle at such distances. If it formed like a brown dwarf, then perhaps it is not a planet in the traditional sense at all, but a small star-like object that never became a star. And if its story is something more complicated, involving movement, scattering, or migration, then the system may have had a violent youth hidden beneath its present quiet. This is the strange thing about a calm image in space. A world can look peaceful now and still carry a dramatic past. The pink planet appears as a quiet rosy point beside a star. But long ago, its formation may have involved enormous forces, gravity gathering gas, objects interacting, orbits shifting, energy pouring into a young atmosphere. The calm glow we see today may be the last trace of a beginning we do not yet fully understand. And so, as we drift beside this distant object, we should let the uncertainty remain. We do not need to force it into a single box. We can call it the pink planet, because that name captures its beauty. We can call it GJ504b, because that is its place in the catalog of science. We can call it a giant companion, because that respects the complexity of what it may be. And we can call it a mystery, because that may be the most accurate name of all. A mystery, orbiting a sun-like star. A mystery, wrapped in salt clouds. A mystery glowing with a faint magenta light. A mystery that may be too massive to be comfortably planet-like, but too small to shine as a star. This is not a failure of classification. It is a reminder that the universe is richer than our categories. There are worlds that are clearly worlds, stars that are clearly stars, and between them, there are dim companions, warm embers, almost planets, almost stars, bodies that drift through the gray spaces of definition. GJ504b lives in that gray space. Or perhaps, more beautifully, in that pink space. A soft, uncertain glow between planet and star. And the more we study it, the more it asks us to think not only about what it is, but about how giant worlds are born. Because the real question now is not simply whether the pink planet belongs in one category or another. The deeper question is how something so large, so far from its star, and so strange in its atmosphere could have formed at all. The pink planet is beautiful from far away. A faint magenta companion. A giant body wrapped in strange clouds. A world, or almost world, glowing softly in the dark. But beauty is only the surface of the mystery. For astronomers, GJ504b is not only fascinating because of its color, it is fascinating because of where it is. It orbits far from its star, very far. In our own solar system, Jupiter is already distant compared with Earth. Earth receives the sun's light from 1 astronomical unit away, 1 Earth-Sun distance. Jupiter moves around the sun at a little more than 5 times that distance. That already feels far to us. Sunlight at Jupiter is weaker. The outer solar system begins to feel colder, larger, and less familiar. But GJ504b orbits its star at a separation close to 9 times the distance between Jupiter and the Sun. If you placed it inside our own solar system, it would not sit near Earth, or Mars, or even Jupiter. It would be far beyond the region where we usually imagine giant planets forming easily. Out there, the star would look smaller. the warmth would be weaker. The disk of gas and dust from which planets form would have been thinner, wider, and more difficult to gather into one massive body. And this is where the problem begins. Because planets are not simply placed into orbit after they are made. They have histories. They have birthplaces. They have violent beginnings hidden beneath calm present-day motion. When we see GJ504b today, we see a quiet companion circling its star. But long ago, that system was young. Its star was forming. Around it was a disk of gas, dust, ice, and rock, the raw material from which planets and smaller bodies could grow. In the standard picture of giant planet formation, tiny grains inside that disk begin to collide. They stick together. They become pebbles, then larger planetesimals, then solid cores. If one of those cores grows massive enough before the gas disk disappears, its gravity can pull in a huge envelope of hydrogen and helium. This is called core accretion. It is one of the main ways scientists explain the formation of gas giants like Jupiter. The idea is patient and gradual. A core grows. Gas gathers around it. A giant planet is born. But this process has a challenge. It works most naturally in regions where enough solid material can gather quickly enough, and where the gas disk remains long enough for a large atmosphere to accumulate. Closer to the star, where material is denser and orbital times are shorter, the process has a better chance. Farther out, everything becomes harder. The material is more spread out. Objects move more slowly around the star. Collisions happen less often. Growth can take longer. And the gas disk around a young star does not last forever. Eventually, radiation and stellar winds clear much of it away. If a core has not grown large enough by then, it may never become a giant planet. So when a massive companion like GJ504b is found so far from its star, astronomers must ask a difficult question. Could core accretion really build something that large, that far out? Maybe. But it is not simple. This does not mean core accretion is wrong. Jupiter and Saturn may still be understood through versions of it. Many exoplanets may form this way, but GJ504b may be testing the limits of the idea. The universe often teaches us by making exceptions. A model works beautifully in one place. Then a strange object appears at the edge of the map, and suddenly the model must stretch, refine, or share space with another explanation. For wide-orbit giant companions, there is another possibility: disk instability. Instead of slowly building a solid core first, disk instability suggests that part of the young star's disk may become gravitationally unstable. A region of gas can collapse more directly under its own gravity, forming a massive companion much faster. This process is more dramatic, less like building a planet brick by brick, more like a section of the disk suddenly gathering itself into a giant body. Disk instability may be better suited to making very massive companions at wide distances because it can act quickly and does not require a core to grow slowly before the gas disappears. But it also has its own challenges. It requires the disk to be massive and cold enough in the right regions. It depends on delicate conditions. Not every disk will fragment this way, and even when it does, the resulting object may look less like a familiar planet and more like a low-mass brown dwarf. This is why GJ504b matters. Its position and possible mass do not point to one simple story. If it is only a few Jupiter masses, perhaps one formation path becomes more plausible. If it is closer to 25 Jupiter masses, as newer JWST-based analysis suggests, then it becomes much harder to treat as an ordinary Jupiter-like planet. It begins to look more like a planetary mass companion near the brown dwarf regime. The recent JWST spectroscopy paper reports a retrieved mass around 25 Jupiter masses and notes that its metal enrichment may tentatively support a planet-like formation, while not fully excluding a more star-like abundance pattern. That phrase, tentatively supports, is important. Science often moves in careful language, not because scientists lack imagination, but because reality is subtle. A single measurement does not always close the case. An atmosphere can carry clues about formation. If a giant object is enriched in heavier elements compared with its star, that may suggest it formed in a planet-like way, gathering solids along with gas. But if its composition resembles the star too closely, that may point more toward a star-like formation process. GJ504b appears to carry hints. Not a final answer. Hints. It may be enriched in certain heavier elements. It may have a composition that leans toward planet-like formation. But the evidence does not completely remove other possibilities. And so the pink planet remains suspended between stories. One story says it was built like a planet, slowly gathering material inside a disk, somehow becoming massive despite its great distance. Another story says it formed more like a small stellar object, from gravitational collapse, never becoming large enough to shine as a star. A third possibility is that it did not begin where we see it now. Maybe it formed closer to the star, where planet formation was easier, and later moved outward. Planetary systems are not always calm in their youth. Young systems can be crowded. Massive bodies can pull on one another. Orbits can shift. Planets can migrate through disks. Some worlds can be thrown inward, toward their stars. Others can be scattered outward into wide, lonely orbits. A quiet orbit today does not mean a quiet past. Imagine the young GJ504 system, not as the calm arrangement we observe now, but as a place of motion and uncertainty. The star newly formed. The disk still present. Gas spiraling. Dust gathering. Young planets or companions pulling on one another. Gravity acting like an invisible hand, changing paths, widening orbits, perhaps sending one object far into the outer regions. If GJ504b was scattered outward, then its current distance would be a memory of ancient gravitational encounters. If it migrated through the disk, then the disk itself may have carried it away from its birthplace. If it formed in place by disk instability, then the outer disk of GJ504 must once have been powerful enough to collapse into a giant companion. Each possibility tells a different version of the same past, and each version changes how we understand the birth of giant worlds. This is why one pink object matters beyond itself. It becomes a test case, a question placed in orbit. It asks, how flexible are our theories? Can giant planets form far from their stars? Can planetary mass companions preserve chemical clues of their origin? How do we distinguish a very massive planet from a low-mass brown dwarf? And how many objects in the universe are waiting in that uncertain space between categories? The more exoplanets we discover, the less our solar system seems like the only possible pattern. At first, we thought planets would mostly resemble the ones we knew. Small, rocky planets near the star. Gas giants farther out. Circular orbits. Orderly systems. But exoplanet discoveries changed that view. We found hot Jupiters, giant planets orbiting extremely close to their stars, completing an orbit in only a few days. We found super-Earths and mini-Neptunes, types of worlds that do not exist in our own solar system in obvious form. We found planets around binary stars, planets in eccentric orbits, planets in systems compact enough to fit inside Mercury's orbit, and giant companions far from their stars. Every new type of world expands the imagination, but it also expands the physics. Theories must explain not only the planets we expected, but the planets we actually find. GJ504b belongs to this larger revolution. It is not simply a pink curiosity. It is part of a much bigger story in which astronomy is learning that planetary systems can be far more diverse than the neat diagrams we grew up with. Some worlds are close to their stars and scorched by heat. Some are cold and distant. Some are rocky. Some are gaseous. Some are covered in lava. Some may have global oceans. Some may have clouds of metal, silicate, ammonia, or salt. And some are massive companions so difficult to classify that they force us to ask where planets end and stars begin. The pink planet sits among these boundary objects. Its wide orbit challenges formation theories. Its possible high mass challenges the word planet. Its atmosphere challenges our ideas of weather. Its salt clouds challenge our imagination. And yet, all of these challenges are gentle in the way deep space is gentle. There is no urgency in GJ504b. It is not rushing. It is not changing quickly for us. It has been circling its star for billions of years. Whatever violent story formed it has faded into the past. Now it moves quietly in the dark, giving off a soft infrared glow, letting only a tiny amount of light escape toward our telescopes. That light is all we have. But that light is enough to ask ancient questions. How did you form? Where did you begin? What did your system look like when it was young? Were you built slowly, grain by grain, core by core? Were you born from a collapsing part of a disk? Were you pushed outward by gravity, exiled from a warmer inner region? Or are you something even harder to name? The pink planet does not answer in words. It answers in spectra. In temperature, in cloud signatures, in chemistry, in orbit, in the faint color of a cooling giant. And that is how astronomy often works. We ask the universe a question. The universe responds with light. Then we spend years learning how to read it. GJ504b is still being read. Its story is not finished. The JWST spectrum has opened a new chapter, but not the final one. More observations, better models, and deeper comparisons with other cold giants may help reveal whether this object formed like a planet, like a brown dwarf, or through some more complicated path. For now, it remains one of the most beautiful kinds of scientific mystery. A mystery with enough evidence to be real, and enough uncertainty to keep pulling us forward. So as we drift beside this world, watching its smoky pink atmosphere turn slowly beneath us, we can feel the deeper weight of it. This is not only a strange sky, it is a strange history. Every cloud above it belongs to an atmosphere. Every molecule in that atmosphere belongs to a formation story. Every trace of metal enrichment, every measurement of gravity, every estimate of mass and temperature carries us backward toward the beginning, toward a young star, toward a disk of gas and dust, toward the moment when this object became itself, a planet, a brown dwarf, a companion, a pink question in the dark. And perhaps that is the best way to leave this part of the journey. Not with an answer, but with a wider sense of wonder. Because GJ504b shows us that even when we find a world, we may not immediately know what kind of world it is. And even when we see a planet's color, we may not yet understand its birth. The pink planet is not only a place with salt clouds. It is a clue to how the universe builds its giants. And beyond it, there may be many more cold, dim companions waiting to teach us that the story of planet formation is still unfinished. GJ504b is not alone in the universe. It feels alone when we imagine it. A faint pink companion moving far from its star. A world wrapped in salt-rich clouds, glowing quietly in the dark. But scientifically, it belongs to a much larger family. A family we are only beginning to understand. Cold giant worlds, dim companions, planetary mass objects far from their stars, brown dwarfs cooling into darkness, massive atmospheres filled with molecules, clouds, hazes, and weather systems unlike anything on Earth. For a long time, many of these objects were almost invisible to us. They were too faint, too cold, too close to brighter stars, too difficult to separate from the glare around them. The universe may have been full of them, but our instruments were not yet ready to hear their quiet light. Hot worlds were easier. Young, bright, massive objects were easier. Planets close to their stars could reveal themselves through transits, wobble, or heat. But cold, wide-orbit giants were harder. They did not pass conveniently in front of their stars. They did not always tug strongly enough for easy detection. They did not shine brightly enough to be studied in detail. They were the quiet worlds, the hidden worlds, the worlds waiting in the dark between stars and definitions. And now, with telescopes like JWST, that silence is beginning to change. This is why GJ504b matters beyond its own beauty. It is not just one pink object. It is a test, a doorway. A first careful step into the atmospheres of cold, faint companions that once seemed beyond reach. When JWST studies the light of GJ504b, it is not only learning about one world's clouds, it is learning how to read atmospheres that are dim, cold, layered, and complex. It is learning what kinds of molecules appear in these conditions. It is learning how clouds hide and reveal deeper layers. It is learning how temperature, gravity, and chemistry work together when a giant body cools for billions of years. And every lesson from GJ504b can help us understand other objects like it. Some may be true giant planets. Some may be brown dwarfs. Some may live between categories, like GJ504b itself. But all of them carry atmospheres. All of them carry histories. All of them release light shaped by their formation, their chemistry, and their cooling. In that sense, GJ504b is like one page in a much larger book. A strange pink page. A page written in salt clouds. But still only one page. Beyond it, there may be countless others. Imagine another cold giant, darker than GJ504b, almost black except in infrared. Its atmosphere may be rich in methane, absorbing light in deep bands, making it look dim and mysterious from far away. Imagine another world, warmer and younger, glowing orange-red, with silicate clouds high in its atmosphere, where mineral particles drift like rock dust in an alien sky. Imagine a brown dwarf cooling over billions of years, slowly changing its cloud layers as its temperature falls, its atmosphere transforming from one chemical state to another. Imagine a planet far from its star, quiet and massive, where ammonia clouds form in the upper atmosphere, like an extreme cousin of Jupiter. Imagine a whole population of worlds with no solid surface, no oceans, no daylight as we know it, but each one carrying its own sky. Some skies may be clear, some may be cloudy, some may be metal-rich. Some may be hazy, some may be stormy, some may be almost still, some may glow with internal heat, some may be so cold and faint that only the most sensitive infrared instruments can begin to study them. GJ504b helps us learn how to approach them. It teaches us that clouds cannot be ignored. For a long time, when people imagined planetary atmospheres, they often thought first about gases, hydrogen, helium, methane, carbon dioxide, water vapor, ammonia. These are important, but clouds can change everything. A clear atmosphere and a cloudy atmosphere may contain the same molecules, yet look completely different to a telescope. Clouds can flatten a spectrum. They can hide deeper heat. They can mute absorption features. They can make a planet appear cooler or warmer, simpler or more complex, depending on how they are distributed. On Earth, a cloud can hide a mountain. On an exoplanet, a cloud can hide a whole layer of atmospheric chemistry. This is one of the great lessons of the pink planet. To understand a world, we must understand not only what gases it contains, but what is floating inside those gases. The sky has texture. The sky has particles. The sky has opacity. The sky has veils. And sometimes, those veils are made of salt. That idea reaches beyond GJ504b. It affects how we think about exoplanets in general. A distant planet's spectrum may look strange, not because our chemistry is wrong, but because clouds are interfering. A molecule may seem weak, not because it is absent, but because something above it is blocking the light. A planet may appear featureless, not because nothing is happening, but because a thick haze is hiding the drama underneath. The universe often hides its complexity behind softness. A smooth glow may conceal storms. A faint color may conceal chemistry. A simple dot may conceal cloud decks, circulation patterns, and deep atmospheric layers. This is why astronomers build models. They do not simply ask, what gases are present? They ask, what combination of gases, temperatures, pressures, clouds, and motions could create the light we see? That question is difficult, but it is also beautiful, because it turns light into landscape. Not a landscape with hills and rivers, a landscape of atmosphere, a vertical landscape, a world of layers. At the top, thin haze. Below that, clouds. Below that, molecular absorption. Below that, warmer gas. Below that, deeper pressure. And still farther down, perhaps conditions so extreme that our familiar language begins to fail. GJ504b gives us one example of such a vertical world. It reminds us that to know a giant planet, we must think downward, not across continents, down through clouds, down through gas, down through pressure, down through chemistry. This way of thinking can also help us understand the giant planets in our own solar system. Jupiter, Saturn, Uranus, and Neptune are not simple. They are familiar because they are nearby, but they are still profoundly mysterious. Jupiter's atmosphere is layered with clouds and storms. Saturn's soft golden appearance hides fierce winds and complex chemistry. Uranus and Neptune, the ice giants, remain among the least explored major planets in our solar system. We have only flown past Uranus and Neptune once, with Voyager 2, just once. Our close-up knowledge of them is still limited. And yet, when we study worlds like GJ504b, we also improve the tools and ideas we use to understand our own giants. A salt cloud around a distant pink companion may seem unrelated to Jupiter or Neptune at first, but the same physics connects them: condensation, opacity, atmospheric circulation, molecular absorption, cloud formation, heat transport. These are universal processes. They happen differently under different conditions, but they belong to the same language of planetary atmospheres. Earth is one dialect, Jupiter is another, Titan is another, hot Jupiters are another, cold brown dwarfs are another, and GJ504b, with its muted magenta glow and salty clouds, is another still. The more dialects we learn, the better we understand the language. This is one of the quiet gifts of exoplanet science. It expands our definition of normal. At first, Earth felt normal because it was the only world we knew from the inside. Then we explored the solar system and learned that Mars, Venus, Jupiter, Saturn, Titan, Europa, and Neptune each had their own realities. Then we discovered exoplanets, and the range of possibility exploded. There were giant planets hugging their stars. Planets larger than Earth but smaller than Neptune. Worlds with years lasting only days. Planets orbiting two stars. Planets so hot they may rain molten material. Planets so dark they absorb almost all incoming light. And now, worlds like GJ504b, distant, dim, pinkish, massive, and wrapped in clouds that may be made of salt. Every discovery moves Earth a little farther from the center of our imagination. Not because Earth is less special, but because the universe is more creative than we knew. Our sky is blue, but skies do not have to be blue. Our clouds are water, but clouds do not have to be water. Our weather falls from above, but weather does not need a surface beneath it. Our planet orbits close enough to the sun for liquid water, but worlds can exist far outside that warmth, still glowing from their own deep heat. The pink planet teaches us that a world does not need to resemble Earth to be worth knowing. It does not need life. It does not need oceans. It does not need continents. It does not need habitability. It can be valuable simply because it shows us another way matter can organize itself around a star. a giant atmosphere. A strange chemistry, a hidden formation story, a sky filled with mineral clouds. These are enough. They are more than enough. Because science is not only the search for another Earth, it is also the search for understanding. Understanding how planets form, how atmospheres evolve, how clouds appear, how heat escapes, how chemistry changes with temperature, how objects cool over time, how the border between planet and star becomes blurred. GJ504b sits at the meeting point of many of these questions. Its color draws the eye. Its clouds draw the imagination. Its mass draws debate. Its orbit draws theory. Its spectrum draws the patient attention of astronomers. And together, these things make it a kind of quiet teacher. Not a teacher that explains itself clearly. Not a teacher that gives simple answers. But a teacher that offers clues. A faint light, a strange color, a muted spectrum, a model that improves when clouds are added, a hint that salt may be floating in the atmosphere of a distant giant. That is how the universe teaches, not with lectures, with objects, with exceptions, with faint signals that do not fit what we expected. A planet that looks too pink, a world that forms too far out, a companion that may be too massive, a cloud that may be made of salt. And when we follow these exceptions carefully, we begin to see the larger pattern. The universe is not a collection of familiar worlds repeated endlessly. It is a laboratory of possibility. Every star system can build something different. Every atmosphere can become its own experiment. Every planet can carry a history that does not match the planets beside it. GJ504b is one experiment. One result of gravity, chemistry, distance, and time. But beyond it, there are many more. Cold giants waiting in wide orbits. Brown dwarfs cooling into darkness. Young planets still glowing red from formation. Old planets almost invisible beside their stars. Atmospheres with clouds we have not yet imagined. Weather systems that no spacecraft has ever seen. And perhaps, in the years ahead, JWST and future telescopes will begin to reveal them one by one. Not all at once. Not dramatically. But quietly. A spectrum here. A faint image there. A cloud signature. A molecular fingerprint. A better model. A new comparison. A world that becomes a little less hidden. This is the slow unfolding of cosmic knowledge. It fits the universe, because the universe itself is slow. Stars form over millions of years. Planets cool over billions. Light crosses interstellar space for decades, centuries, or longer. And then, one night, that light enters a telescope. And someone, somewhere, notices that a model works better when the clouds are made of salt. It is a small moment, but it changes the way we imagine the sky. So as we leave this part of the journey, we can think of GJ504b not only as the pink planet, but as a doorway into the cold and quiet side of planetary science. A doorway to giant worlds far from their stars. A doorway to atmospheres without surfaces. A doorway to clouds made from minerals. A doorway to the idea that there are many kinds of weather, many kinds of worlds, many kinds of glow. And beyond that doorway, the dark is not empty. It is filled with dim companions, waiting, cooling, turning slowly around their stars, carrying skies we have not yet named. Now, after all the distance, after all the light, after the spectra, the molecules, the clouds, and the questions of origin, we can finally let the science become an image again. We are approaching the pink planet, not as astronomers at a desk, not as data on a screen, but as travelers in a silent spacecraft, drifting through the outer darkness of another star system. Ahead of us, GJ504b grows larger. At first, it is only a dim rose-colored point, almost lost beside the much brighter star it orbits. Then it becomes a disk, then a sphere, Then a world so large that it begins to fill the window. The blackness around it seems deeper now. The stars behind it fade, where the planet's dark limb cuts across them. The star GJ504 shines far away, not like the sun from Earth, not large and warm and familiar, but as a bright, distant source, a reminder that this is not our system, not our sky, not our home. The pink planet turns slowly beneath us. Its color is difficult to describe. Not the clear pink of a flower in daylight, not the bright pink of something artificial. It is dimmer than that, older than that, a smoky magenta, a faded rose, a dark cherry blossom glow mixed with violet, brown, gray, and shadow. It is the color of a world still cooling from its beginning, the color of heat leaving a giant atmosphere, the color of a mystery seen through infrared light and translated into human imagination. We drift closer. The curve of the planet expands. The upper atmosphere appears soft at the edge, not sharply cut like a solid body, but slightly blurred, as if the world fades into space through layers of haze. There is no surface, no continent, no ocean, no shore, no frozen plain, no mountains catching distant sunlight, only atmosphere, a vast, bottomless sky wrapped around an enormous mass. From far above, the cloud layers do not look like Earth's clouds. They do not form small white patches casting shadows over land. They are broader, smoother, stranger. They move in bands and veils, subtle and deep, wrapped around the planet in quiet patterns. Some regions seem darker, as if thick clouds are hiding the glow from below. Other regions appear softer and brighter, as if heat is escaping through thinner places in the atmosphere. Nothing moves quickly from this distance. The scale is too large. The planet does not seem to rotate so much as breathe. Slowly, silently, patiently. A giant turning in the dark. Somewhere in those high, cloudy layers, salt-rich particles may be drifting. Tiny mineral grains suspended in alien air. They do not sparkle like crystals on a beach. They do not fall like snow. They are too small, too distant, too deeply mixed into the atmosphere for anything so simple. They are part of the planet's veil. A cloudy layer that changes the light. A soft mineral curtain between the upper atmosphere and the warmer depths below. We pass over the limb of the planet, where day and night do not mean what they mean on Earth. There is no blue sunrise, no golden morning, no line of sunlight moving over mountains. Instead, the distant star throws a faint illumination across the upper haze, while the planet's own internal warmth glows from below, in wavelengths our eyes were never made to see. The edge of the world seems to hold two kinds of light at once. Faint starlight from outside, faint heat light from within, a distant sun above, an ancient ember below. Between them, the clouds. Salt clouds, pink haze, deep atmosphere. For a while, we simply drift. No need to explain, no need to measure, only watch. The planet's face changes slowly as we move beside it. A darker band curves across the northern hemisphere. A broad region of muted rose fades into a smoky gray. Near the edge, the atmosphere thins into a delicate rim, and beyond that rim, the universe continues, black, cold, and full of distant stars. If this were Earth, we might search for signs of life. City lights, cloud shadows over oceans, lightning storms, the blue reflection of water. But here, there are no cities, no coastlines, no forests, no night-side glow from civilization. There is only the glow of the planet itself, a world not made for us. And perhaps that is part of its peace. So many human stories are about finding another home, another Earth, another blue planet, another place where oceans might shine beneath a breathable sky. But GJ504b is not that kind of dream. It is not a promise of life. It is not a future destination. It is not a second home waiting quietly for us. It is something else. a reminder that the universe does not exist only to mirror Earth. It creates worlds for no audience. It makes skies no one has stood beneath. It forms clouds that may never rain on ground. It gives color to objects that no eye could see up close. It allows giant companions to circle in the dark for billions of years, whether or not anyone ever learns their names. And now, for a brief moment in imagination, we are here, beside one of them. The pink planet fills the view. Its clouds drift below us. Its atmosphere looks soft, but everything about it is extreme. The gravity, the pressure, the depth, the heat stored inside. The chemistry suspended in its layers. If a probe were dropped into this world, it would not fall toward a landscape. It would sink through haze, then cloud, then deeper gas. The pressure would climb. The outside light would vanish. The atmosphere would grow thicker and hotter. The concept of sky would blur into the concept of interior. There might be no final arrival. Only descent. Only depth. Only a world that becomes more itself the farther down you go. But we are not descending. We are only passing by. We stay high above the clouds, where the planet can remain beautiful, distant, and whole. From here, GJ504b looks almost peaceful. A quiet, rose-colored sphere. A soft companion beside a bright star. A body moving along its wide orbit, unhurried by human time. Its year is long. Its path is broad. Its seasons, if they exist in any meaningful way, would not feel like ours. The rhythms here are not measured by days of rain or snow. They are measured by rotation, cooling, circulation, chemistry, and orbital time. The slow mechanics of a giant world. As we glide along its side, the star appears over the planet's edge, a small, brilliant point rising behind the haze. The upper atmosphere catches a faint line of light. For a moment, the pink rim brightens. The salt-rich cloud layer, invisible in detail but present in the story of the light, seems to glow like a thin veil around the world. It is only an imagined view, but it is built from something real light, real spectra, real molecules, real models, real uncertainty, and real wonder. That is the balance we carry through this journey. We do not know every detail of GJ504b. We do not know exactly how every cloud looks. We do not know every motion in its atmosphere. We do not know with final certainty whether its origin was planet-like, brown dwarf-like, or something between. But we know enough to let the mind approach it. We know it is distant. We know it is massive. We know it glows faintly. We know its atmosphere contains chemical fingerprints. We know clouds are needed to explain its light. And we know salt-rich clouds may be the best match. That is enough for awe. Not certainty. Awe. Certainty is not always required for wonder. Sometimes, wonder begins in the space between what we know and what we are still trying to understand. GJ504b lives in that space. It is a world of partial answers, a pink glow that raises questions, a spectrum that opens a door, a cloud layer that changes the story, a giant companion that refuses to sit neatly inside one category. As we pass over the night side, the planet becomes darker. The rosy color fades into shadow. Only a dim thermal glow remains in our imagination, a soft warmth leaking outward through deep layers of gas. The star is hidden now behind the curve of the world. The spacecraft window fills with darkness. For a moment, the pink planet seems almost gone. Then, slowly, as our path carries us onward, another part of the atmosphere appears. A faint rim, a whisper of magenta. A cloudy edge returning from black. It is easy to imagine that the planet has been doing this forever. Turning, cooling, clouding, glowing, long before humans built telescopes. Long before JWST unfolded its mirror. Long before anyone on Earth gave this object a name. It was already there. moving around its star, carrying its atmosphere, forming and dissolving clouds in silence. The universe is full of such places, worlds that do not wait for discovery because they do not know discovery exists. They simply are, and our knowledge of them arrives late, a small signal after a long journey. A few photons after 57 years, a spectrum on a screen, a paper, a model, a phrase that suddenly feels like poetry, clouds made of salt. The spacecraft continues forward. GJ504b begins to fall behind us. At first, it is still enormous, filling the side windows with its muted pink glow. Then the curve shrinks. The cloud bands become less distinct. The darker regions soften. The atmosphere becomes smooth again. A world becomes a disk. A disk becomes a point. A point becomes a faint rose-colored star-like speck beside its brighter sun. And yet, it is not the same as before. When we first saw it, it was only a distant pink light. Now it carries meaning. We know there may be salt in its clouds. We know its atmosphere is a layered place of molecules and haze. We know it may be heavier and stranger than the word planet first suggests. We know its existence asks questions about how giant worlds form, and we know that somewhere in the quiet space around GJ504, a massive companion is still turning, still cooling, still hiding most of itself from us. This is the gift of a flyby, even an imagined one. It allows a scientific object to become a place, not a place we can touch, not a place we can visit, but a place we can hold in the mind. A pink giant in the dark, a world without ground, a cloudy atmosphere where salt may drift, a silent reminder that the sky is not one thing, it is many things. On Earth, the sky is blue and filled with water clouds. On Mars, it is thin, dusty, and salmon-colored. On Titan, it is orange with organic haze. On Jupiter, it is striped with storms. On Neptune, it is deep blue and windy beyond imagination. And around GJ504b, the sky may be magenta, cold, and veiled with mineral clouds. A different sky, a real sky, a sky that belongs to a world no human has ever seen, directly with their own eyes. As we leave it behind, the darkness opens again ahead of us. The star system grows smaller. The pink planet fades, but the thought remains. Somewhere out there, far from our sun, the universe has made a pink world with salt in its clouds. And perhaps, across the galaxy, it has made many more skies just as strange. Skies of minerals, skies of methane, skies of ammonia, skies of iron, skies of silicate dust, skies we have not named yet. The pink planet is only one example. One quiet wonder among billions. And as it disappears behind us, we are left not with an ending, but with a larger sense of space. Because if a world like this can exist, only 57 light-years away, then what else is waiting farther out? What other colors? What other clouds? What other kinds of weather? What other worlds that do not resemble Earth, but still reveal the creativity of physics? We move onward through the dark. Behind us, GJ504b continues its long orbit. Ahead of us, the stars wait in silence, and between them, the mind can rest. Because sometimes, the most peaceful thought in astronomy is also the most profound. The universe is not empty. It is full of places. Most of them are not for us, but they are still real, still beautiful, still turning, still holding their own quiet skies.